goal is to talk about the silver lining. I think even in my situation where I am in the hospital, the silver lining is that I can present using Zoom, which is an amazing opportunity for us. And I would like to, just one moment, excuse me, I'm just removing. I would like to tell you what I will talk about. So I would like to talk about STEAM education. So why another letter? Why now? Then we'll talk about the challenges and possibility and the implications for teacher education. As Maya said, I do work at the University of British Columbia, and I work in teacher education, in science teacher education. And I will bring a couple of examples from the University of British Columbia. It is very exciting that we have an international conference and we can share experiences from different parts of the world. And then we'll talk about some lessons from the pandemic. And finally, I would like to talk about opportunities for research and practice. And I will try to leave about 20 minutes for questions and answers. I hope that you will ask me questions. Even if I don't know the answer, it will give me an opportunity to think about new ideas. So I just wanted to say that what an exciting opportunity it is to present through Zoom. And it is, I did need to fly to Finland, although I would have loved to, but right now it's not possible. So despite that, we're still capable to collaborate, to learn from each other. So I think it's a very exciting opportunity to be able to do that. And today, I would like to focus on the balancing act of STEAM. So why am I talking about the balancing act? Because when you try to put more, at first we were preparing science teachers, then we put technology, engineering, then we started adding arts or other subjects and mathematics. The more you put in, the more you're trying to balance and figure out, are we going to have a curriculum that is a mile wide and an inch deep? In other words, something has to give. So how do we do that? That we can balance it all. And actually, this is the picture from Vancouver with the balancing rocks. But I think very often what we have to do as teacher education is as much balance as this one. So let me start with let me just one moment, I'm going to remove this. Okay. Let me start with the definition of STEAM. And the way I see it is STEAM originally meant to science, technology, engineering, arts, and mathematics. And it's actually an access point for guiding inquiry, dialogue, and critical thinking. So my question to us, do we need arts to make STEAM creative? While preparing for this presentation, a lot of people wrote about the lack of creativity in science, and art will make it creative, or other subjects. I have to disagree with that because I think science and technology and math, they all require lots of creativity. So there are different dimensions of creativity, but a lot of it is very creative by itself. So here I put some pictures from the inventions of Leonardo da Vinci, and I think it's one of the most creative things that humans have created. So my question to myself or to you is, what does it add to learning? So we are going to add more, and how do we, when we add more, how do we make it meaningful? How do we go beyond the acronyms? And thinking about it, I was thinking about the School of Athens, and it's a famous fresco by Raphael. And in this fresco, you can see in the middle, you can see Plato, and you can see Aristotle, and you can see on the left, you can see Socrates. So that's a very famous fresco. It's a work of art, but it all based on every person here in the picture represent different philosophers or different uh, natural philosophers. I don't want to call it scientists, but this is, to me, is a beautiful combination of art and sciences. But now you can also see here on the right the goddesses of art and science in Greek mythology. Again, you can see the art and science coming together. The question is, How do we do that? How do we do it in a meaningful way? Of course, you can talk about Leonardo da Vinci, but can we expect to teach everybody to be like Leonardo da Vinci? Da Vinci was one of the very few people who was able to combine it. Maybe Antoni Gaudi, who was an amazing mathematician and architect, who an engineer who built that Sagrada Familia in Barcelona, or Richard Feynman, who was very creative. And for example, that's an example of famous Feynman diagrams that helped reconsider uh, how we think about quantum mechanics. So there are different dimensions of creativity. Why STEM? And here, the biggest question that I want to ask myself is, how do we open up STEM without making it shallow and meaningless? What are the big STEAM ideas? And here I try to think of different kinds of knowledge that come to my mind when I'm thinking about it. So for example, I think that in order to be an effective STEAM teacher, you have to have extensive knowledge in different subjects. That's a challenge. Now you also have to have cross-discipline knowledge. It's a big skill of a teacher to be able to connect between different subjects. So for example, if you're teaching science to connect it with technology, mathematics, or arts, it's not easy to do it in a meaningful way. But most importantly, you have to see big ideas. The big ideas that actually come cross the subject boundaries. And again, this is a big challenge for teacher education. How do we educate teachers so they can see and understand those big ideas? How do we support teachers who in professional development or in other opportunities so this is not overwhelming for them? So here, for example, I put a picture of the Boundary Bay in Vancouver, British Columbia. And while looking at this picture, I can think of many intersections between the arts and the sciences. For example, you can think of the shape of the clouds. You can think of the red sunset, and you can ask, why do we have it red? You can ask lots and lots of questions, but in order to inspire the students to delve into them, the teachers have to have this knowledge. And I think that's where it becomes very difficult. I know how we prepare teacher at the university, prepare teachers at the University of British Columbia. We prepare teachers actually only in an 11-month program. So to help teachers be curious, creative, and build those connections, it requires additional professional development post teacher education. So let me just give you a few STEAM examples that came to mind right away. So for example, Pythagoras. I cannot think of a better connection between music and science and mathematics than the school of Pythagoras. This is on the right, it's inside the Sagrada Familia. Actually, Gaudi, when he was building his masterpiece, La Sagrada Familia, when he was building that, all the curves there were they were mathematical curves. So to build this, he was a mathematician. He calculated and engineered everything. So when you visited, when I visited, I was just amazed how mathematics and science and technology actually came together to build such a masterpiece. I think it's going to be completed in a few years. I think in a couple of years, it will be completed. So I also think that we can look at bridges. Again, it is art, it is science, it is technology. And on the left, it's the famous Golden Gate Bridge in San Francisco. On the right, it's a famous, as far as I know, bridge in Helsinki. So a lot of bridges, they're again a masterpiece and the combination of mathematics, art, and science. But how do we educate teachers who can support students to explore this? So I was thinking about it, and I was thinking that for me, you have to put the 3K plus model. So let me go back for a moment and remind you what I mean by 3K. So it is the content knowledge, the cross-STEM discipline knowledge. So first you look at the knowledge of the subject, for example, science, mathematics, arts. Then you look at the cross knowledge, the knowledge that how those subjects are connected, interrelated. And then the big ideas, encompassing big ideas, big picture knowledge. And so and plus the curiosity, creativity, and connection. So that's why I called it 3K plus model. So let me just give you another example. So for example, you have here the plane, the thin air. And if you think of the plane, I feel there is so many connections here. For example, you can consider flying from the perspective of science. Yeah, you can look at the forces. Actually, a lot of people think of the Bernoulli's effect on the wing, but actually the traditional explanation is not accurate. The one that you will find in most textbooks is incorrect. Um, you can also think, of course, related, you can think of the clouds, different shapes, you can think of turbulence, you can think of weather, you can think of the materials the plane is made of. You can go back to Leonardo, who was the first one, who were one of the first people who were considering uh, how to build those flying machines. And of course, you can think of the engineering and material science. Actually, a lot of technologies today rely on the new materials that we have. So if you think anything, it's only one example. If you think of this example, you can think of how different subjects come together, and you can help your students explore that. But my question to you and to me is, do teachers have the time to explore those connections? How do we support teachers to help them build these team models? Now, a lot of people will say you just give the students to explore, they will do it. But I think it's also important that the teachers have knowledge, the necessary knowledge, so they have the vision, they can support the students and help them guide their discovery. Now, I would like to share with you a few of the challenges of STEAM education in Canada. I know that in Finland, you educate teachers very differently compared to us. So I know it's not the same, but it's important for us to know what's happening in different countries so we can learn from each other, and we can actually maybe think how to re-envision our teacher education. So in Canada, I think the biggest issue how we educate future teachers is the knowledge base. So teacher education in Canada is usually relatively short. I'm saying in Canada, although I have to qualify, I'm mainly focusing on British Columbia, because in Canada, education is a provincial responsibility. So has its own um, every province has its own teacher education, its own rules. So for example, in British Columbia, we have an 11-month teacher education program. In Ontario, they have 2-year teacher education program. In different provinces, we have different rules. But in any case, teacher education is a relatively short opportunity for future teachers. And I have to say that all of them, and I'm talking now about teachers who are going to be um, certified teachers, all of them have to have a bachelor degree in a subject before going into teacher education. So for example, if you want to become a mathematics teacher, you're going to have a degree in mathematics, and then you're going to pursue a teacher education program. Now, even in our framework, if you think of teacher education, we do not certify, of course, STEM teachers. We are very compartmentalized. We, for example, science and math exposure for our students in K through 12, they're all exposed to that, but then teachers who become elementary teachers might not take math and science beyond the secondary school. They have a requirement of the minimum, I think, 1 lab course, but it's relatively small. If you want to be secondary physics teacher or math teacher, again, we don't educate STEM teachers. So we don't have the vision to educate people who will cross the subject boundaries. Those teachers will have Bachelor of Science before they can come to become secondary teachers. However, even though we educate only math teachers or science teachers, you never know what science you will be teaching as a teacher in Canada. So for example, if you started as if you were educated as a physics teacher, when you arrive at a school, you might be asked to teach biology or chemistry. Moreover, in grades 8 to 10 in secondary schools in Canada, all our teachers 8 to 10, they will be teaching all the sciences. So that means that even though we educate teachers as a math teacher or a physics teacher or a chemistry teacher, we know that we don't know what they will be actually teaching. So even though we don't educate STEM teachers, a lot of teachers at work have no choice but to cross those boundaries. So that's what I just wanted to say, that we call it bachelor in a subject, and then it's called bachelor of education, but the bachelor of education is an add-on program that lasts only 11 months. So for elementary or secondary, and most elementary teachers would be the teachers who came um, with the degree in the arts, they would maybe English, arts, or some other subject. Most of the secondary teachers are the teachers who came with a degree in whatever subject they would like to be certified. But being certified in a subject in Canada does not mean that that's what you will be teaching. So I would be very much interested to know, how does it work in Finland? Can a teacher who is, for example, a physics teacher be asked to teach chemistry? Or do you educate STEM teachers, teachers with a vision that they might be teaching different subjects? And here I would like to tell you a little bit about the UBC teacher education. And so to give you some examples of what we're doing to promote this to promote this team at UBC. So that's our university. We have, it's a big public university. It's the biggest public university in British Columbia. We have 2 campuses and about 65,000 students. We are about 35th ranked worldwide. And I know it's not very modest, but I think we have the best teacher education program in the province. And we have it varies. Right now, I think we will have um, about 750, 800 teacher candidates, but it uh, varies from year to year. And what I mean by teacher candidates is future teachers. Uh, so let me just give you a few examples how we're trying to promote STEAM, how we're trying to promote this collaboration crossing the subject boundaries. So I will give you a couple of examples. The first example that we started 10 years ago, it is a family math and science day. A family math and science day is an open house where our teacher candidates collaborate to share the science, engineering, and math, what they're passionate about, with the general public. For example, last year, we had more than 650 guests. We have all the labs open. Teacher candidates prepared their own stations, and we used those stations so they were explaining those experiments to the general public. And you can see we had a lot of people with the parents, grandparents, children, lots and lots of different people. So has become very, very popular event. The second, and again, the reason I'm saying it's STEAM, because this event actually crosses the boundaries. We have elementary and secondary teachers collaborating, sharing something they're passionate about related to science and arts or music. So let me just give you one example. For example, we had future music teachers and science teachers and math teachers collaborating on explaining how musical instruments work. And they also explained how opera singers were able to modulate their voice to have the range when they sing. So it was a collaboration between the students. So some students do collaborative projects, some students don't, but a lot of those projects are actually collaboration between the sciences and the arts. Now, The second event that I would like to show you is the UBC Physics Olympics. This event has been running for the last 41 years. I have to say that for the first time in our history, as far as we know, we had to cancel it this March, which was a very difficult choice for us. And this is an event where a lot of students collaborate in teams from all over British Columbia, and those students participate in different competitions. Some of it they're doing on campus, figuring things out on campus when they come to us, but some of those they're preparing at home. We have two events in this competition, UBC Physics Olympics, that we call them pre-builds. So they have a challenge and they have to pre-build it at home. So again, you have the cross boundary here. You have technology, you have science, you have mathematics, so of course physics. So the students work collaboratively um, to to solve challenges. Most importantly, it's not an individual science Olympics. It's a very group project. So, and it's a very exciting project. For example, a year ago, not this March, but the previous March, we had 720 students from all over British Columbia. Some students came, flew, some students came by car. So they came from all different areas of British Columbia, which means some had to drive for 7-8 hours to arrive to UBC. It was a very big deal. And also, I would like to talk to you a little bit about creative use of technology for STEAM projects. So where do we have technology? For example, how do we use technology? We use technology in many different aspects. For example, a lot of our labs use smartphones and sensors, but we also use technology to share ideas with other teachers. As I mentioned before, one of the challenges is that um, teachers don't always have the opportunity to actually to prepare. How can I say that? Teachers do not always have the time to prepare new experiments, to learn new things. So what we have decided that after the Family Math and Science Day, our teacher candidates have created very short videos. The videos were about 3, 4, or 5 minutes long videos with all those experiments that they had shown. So our teacher candidates shared what they have done with the bigger community. And that's one use of technology that I find very valuable, because it allows us to share with other people and to learn from each other. So that's a few photos from the UBC Family Math and Science Day. You can see how involved teacher candidates are. And all of those experiments you can find on my blog, tiny videos of those experiments with the explanations how they can be conducted. Now that's a few photos from the UBC Physics Olympics. You can see that's the last ceremony in the middle, but you can see that all the things that they're doing this in teams. And we have a lot of students who, for them, that's the first time to come to a big city, to see a big university. It's a very big deal for many students to come to the university and to do something as a team, to see a real science lab, to collaborate. It's very exciting. And I just wanted to show you that's part of the British Columbia. And you can see that the distance, for example, from that is UBC, you can see most of the schools are here, but you also have schools on the island. We have schools in Kelowna, we have schools all over the place. And so, you know, that's about 400 kilometers. So the distance here, so it is pretty far away. Now, I also would like to share with you that I have a concern about this trying to achieve it, because sometimes you can say that we are trying to create curriculum that is many feet wide and only a few inch deep. So every time we design something, we have to think, how do we create a wide curriculum, but it is also many inch deep. It's not shallow. And one way of doing it is also creative use of technology, is using computer simulation. Here, I hope that a lot of you may know that it's a FET website with free computer simulations that we use extensively in our science teaching and mathematics. So this is a collection of very nice computer simulations that you can use with your students. And actually those simulations also have activities that are created by teachers, and teachers donate their activities to share with others. So that is, you can find it on my blog. So that is a collection of many, I think almost 80 computer videos, very short videos created mostly by our teacher candidates, that of the experiments that they have done. And that's a very interesting also process. When you're creating a video and you're creating a video to share with the teachers, you have to think not only of it's an educational video, you have to think not only of the content of the video, but also how do you use this video as a teaching tool. So our teacher candidates think about the resources teachers have to have, about they do give suggestions to teachers, what are the extension activities, they discuss what you can do with this activity, what are the resources. So those tiny videos are created for teachers and of course for students, but mainly we created them for teachers who can go to schools and use those activities in their classes and experiments. So now I would like to focus in the last part of my presentation on STEAM education and the lessons from the pandemic. And I'm going to move it out. Yeah. The lessons from the pandemic. So what have we learned, at least in British Columbia, from what has been happening? I think the biggest thing that we have learned, and that really applies to STEAM education, is that there is a huge difference between remote teaching and quality online education. Doing the same thing that you were doing in class or uploading your videos or resources does not mean that you created online quality online education. So we have to learn how to teach online. We also learned how much we can do with online resources. For example, a lot of our teachers now teach via Zoom or other tools, and now they had to learn this time very quickly how to do that. But I think now it will be something that they'll be using in the future. So I really think that now we have the openness for online sharing and collaboration. Even how we're doing this conference today, we wouldn't be that open to use Zoom, for example, or other tools to create a conference. And now we realized what an amazing opportunity it is. Now, we also realized with the with the pandemic, how important it is to engage parents. And I live on UBC campus, and we have done quite a few activities for the local communities for the parents. How can the parents support their students, their children? Because a lot of parents, they don't know what's the curriculum. How do I help my child? What can I do? So we have to work with the parents, because parents play a big role in the education of their children. So we need to think not only of educating students, but engaging parents as well. But I think, the biggest issue that we realized, that the balance is the big problem. We have lots of resources. We have, you can watch videos, you can watch people share STEAM resources. It's amazing. I put a few links here, and this presentation will be shared with you, so all the links are there. But you can easily overwhelm people with the resources. How do we make those resources meaningful, that they're not just more and more and more, and then the people just shut off? How do we engage the students? How do we deal with the social aspect? A lot of students suffer from not being able to meet to be socialized with their friends. So how do we balance online versus face-to-face? How do we open the A with the online resources? I think the pandemic taught us that in a STEAM, we can much more easily connect different subjects, but again, it requires time. It requires teacher collaboration. And I think it's important for us to realize that. And I also would like to talk to you just to mention also the use of technology. It is, technology has to be used deliberately and purposefully. And it's really important for us to realize that, because yes, there are many tools. There are a huge number of websites and whatever you wish, but why do we use them? Which one do I use? How do I decide if this tool is useful for me or not? And this brings me to another aspect that I think we realized during the pandemic. At UBC, we have online teacher education programs. We have online, we have a teacher education the reason we have online programs as well as face-to-face. And we have in our group, we have online in math, master in math education, master in science education, and master in museum education programs. And the reason that we have programs online is because a lot of teachers live far away and they cannot just arrive to UBC. In addition, a lot of teachers, even if they live in Vancouver, they work full-time. So they need another option to educate themselves. And again, I think that today, more and more people will consider online professional development for teachers. So that would be something I'm very interested to work on. How can we work on teacher education, on online opportunities for teacher education? So we can not only teach education, but teach a professional development. This will open those opportunities for teachers who might not be able to arrive to the University of British Columbia or other universities. And if any of you are considering starting the online Masters in Education program, I'm more than happy to share our resources and tell you how we have done that. So the questions that I would like to leave you with are, how do we learn from the past to promote the future of STEAM education and teacher education? So what have we learned from the pandemic? What have we learned from the past? How do we open STEAM, but in a meaningful way? How do we use this experience to break traditional walls and establish new collaboration? How do we choose effective technologies and online resources to promote STEAM education? And how do we promote meaningful face-to-face and online STEAM education and teacher education? I think after the pandemic, a lot of people will be more open to online education. A lot of teachers will be open to online education. So maybe online programs, master's program for teachers, those are the programs that will help teachers to break those walls of STEAM and also to get the professional development that wouldn't be possible for them face-to-face. And most importantly, how, for me, because I'm an educator, an educational researcher, how do we research STEAM education? What questions do we want to ask? How are we going to respond to those questions? How do we collaborate to answering and asking those questions? So I think that those are the questions that I would like to leave you with. And here I would like to finish, it's another picture from Vancouver. So to finish with the idea that, or thought that it came to me. So each one of us has to discover our own balance and decide what we want to achieve with our students. A mile wide or an inch deep STEAM curriculum, or maybe something in between. And each one of us has to figure it out for ourselves. And now here's my picture of the silver lining of the pandemic, and I'm more than happy to try to answer some of your questions. Thank you very much.